Dr. Roberto Araya. Dr. Roberto Araya is an associate researcher at the Center for Advanced Research on Education at the University of Chile. He holds the PhD in Electrical Engineering from the University of California at Los Angeles and Master in Applied Mathematics from University of Chile. He is the founder of AutoMind, artificial intelligence solutions for banking, retail, mining, and educational sectors. He is also a member of BrainQuake, a Stanford University spin-off that builds mobile math games, and a member of the APEC Innovation in Mathematics Education through Lesson Study Project. He wrote a number of papers on mathematics education, online learning, and teacher practices, as well as mathematics books and online course. He obtained the Best Paper Award in the International Conference on the Web-Based Learning held in Hong Kong.
Ladies and gentlemen, please join me to welcome Associate Professor Dr. Colin Eddy and Associate Professor Dr. Roberto Araya.
Hello, thank you. We do have one more person to introduce, and that's Joseph Williams, also from the University of Chile, who is very instrumental in what we're presenting today and is a contributor, and so will be presenting with us as well. First of all, we want to recognize Professor Maitre and Professor Masami for directing us through APEC. And sorry about that. And also, we want to recognize those who were involved in this project with us. And we are probably missing some people, so if we are, we apologize, but we wanted to include everyone who is involved, including some of our other APEC specialists. So part of the project, being a part of APEC, was to create a lesson on energy efficiency. But that's just a part of it. The other part was to make it relevant across borders within classrooms. And what we experienced last February as part of APEC at the conference was a demonstration of the possibilities between Malaysia and Japan. So we actually saw a demonstration lesson of that. And then each of us brought ideas of possible lessons. And what we are going to discuss here is the team that was created between the Americas. And so we are going to present that to you. So here is just an overview of the process that occurred from last February to this October. And as you can see, a lot has occurred within that amount of time. And our team included our colleagues from Mexico, Peru, Chile, and the US. And then there were 3 central questions at that conference to stimulate our discussion and our activity. And so they are, what is the major issue facing energy in your economy? And in relation to science, technology, engineering, and mathematics, what reforms are taking place in your economy? And in relation to lesson study for cross-border, what possibilities do you have? So with that in mind, Roberto had some graphs that he pulled from that. Do you want to speak to this?
Yes. Well, this question is very interesting. The need of energy efficiency. So how can we approach this problem? This is a recent book from Stanford professor, and he has this last 16,000 years. And the energy captured per capita means per each person per day. This was around 16,000 years ago, means 40,000 before the Christian era. The amount of energy people capture. These are hunter-gatherers. And through the history have been very stable. Around year 0 Christian era increased a little bit. But in the last 100 years explode. It's really explode amount of energy we all of us capture per day. It's 50 times this amount of energy. So means it's a big increase in our society. And you would think in those times, where were the energy capture? Mainly, and this is what we discussed with the students, mainly from food. But we were not eating 50 times more. So where is all this coming? And this is a big explosion. And the next one, this is America, United States, how much energy they capture per day. This is Japan. This is the last 20 years. They are going a little now more efficient. But these are the other countries. This is Chile, Brazil, Mexico, and we're increasing. We all want to be like the States and in Japan. We want to live in the same way. But this means increasing energy. And most of the countries are in this region. And most of us want to be like them. And that means a lot of energy. Only 10% of the population live here. 90% live here. And we want to be like them. That means a huge problem for all of us. So that's something that we wanted to make the student think. So what makes it the problem behind?
So what we want to do is let's take a minute with the goal of the lesson was to recognize the cross-cutting nature of energy, its relations to physics, biology, social development, and recognize the need to work together to improve energy efficiency. But first you have to connect it to students, give a context. And so I'm going to let Roberto provide an activity for us. So if everybody will stand.
Yeah. So the next, can you show the next? The next. Yeah, you know, energy is a not easy concept, but it's a cross-cutting concept. It's in physics, in chemistry, in biology, social science. So, and then we need to know what is a kilocalorie. The previous graph showed that the kilocalorie per day that we capture, and kilocalorie per day per capita, per person that we capture. So how can we understand this idea? How we can touch this idea of energy? So I need your help for this, and this activity we did well this year. We need all of you to stand up. Please stand up. Now, Joseph, can you help us? Okay, so we're gonna do an activity, and we're gonna just jump the following way.
Do we want to do a demonstration?
Patsy, can you help us with more energy? We need more energy. Okay, let's go again. 1, 2. Well, okay, thanks very much. So what do you feel with this, Patsy? This energy?
We didn't do it long enough.
Yeah, we don't. Is this related to energy? In what sense is related?
Maybe kinetic.
Kinetic?
Kinetic, maybe. Kinetic.
Motion? What else do you feel with this activity? I mean, if we would have, Patsy said we didn't do long enough. Let's say we would keep trying this. What do you think we will feel? warm, heat. Okay, good. So next. So, here we have to show, this is a teacher. Let me see here.
So while Roberto's getting that video up, this is the lesson implemented in one Chile classroom.
The sound. Well, it's too dark. That's true. We wanted to see, in Chile, in winter is very cold. We don't have a lot of energy to heat the classroom. So the natural way to heat them is wait that enough children go for a while. But there was another way. Have all of them jumping. So they would start to jump, and we put some thermometers, and we look at how the temperature was going to increase. We did it in two conditions. First, just sitting like you are doing now for 10 minutes, not for just half a minute like you did. And the other condition was jumping for 10 minutes and see how the temperature would increase. So the next one. Oh, sorry. Okay, this is one. That's where we were at. But you know. No, but look at this, what happened.
I know, but it's because we're not in presentation.
Oh? What? Huh? What this? Where we are? No, here.
Yes.
I don't know what happened. Oh. And how do we show this? No, that's.
I don't see the presentation.
Huh? Oh, now we are. So we have two conditions here. It's okay. In the left was just sitting for 10 minutes, and we have two thermometers. And the right, we were jumping. And you know, what happens when we jump? We produce heat. And heat is one of the main notions of energy. So raise the temperature. The concept of unit of heat, calorie, is the amount of energy we need to raise 1 gram of water 1 centigrade Celsius. So the question for the kids was, so this was increasing the temperature, so we get into the physical notion of energy, of heat, calorie. But then we had several questions for them. For example, think about this. If we keep doing this, the temperature will increase, but why then it stops increasing? Any ideas why this doesn't continue increasing the temperature? Because we are producing heat. Why doesn't continue increasing the temperature and get to an equilibrium? This was one question. The second is, the temperature level, in what variables depends? How much is going to increase? In what things will depend what the temperature will increase? What are the possible variables? One would be how much we jump. Patsy said 7 more minutes. What else? Well, what we did here is that the picture was very dark. Why was dark? Because we opened the window, we get heat from outside. So we also needed to turn off all the lights. We want just to control all the heat produced by the kids, not from outside. What else will depend? What other variables will depend? So we have them think about this. What other variables? And here are some of them. You know, we have all of them jumping, not with this little thing, but with a bigger one. And what else? Other variables? What other variables will depend how much the temperature will raise? Can you think? The room. But then is it the length of the room, the area of the room, the size of the room? Size, what is the size? The dimension? Can you be more precise? We have a different measure of size, length, area. What else? Volume. Volume. So depends very much on the volume. But let's say this is a high ceiling, then will not raise as much. So this gives to the mathematical notion of volume. So we have this small model of the room, and volume is not easy for the students. So they have would be like 1 cubic meter of air, water or air. So they have to see how many of these occupy the whole volume of the room. So this was a small idea of the room, and this is the cubic meter of air. And then you will need some energy for that. But energy is very abstract. So we use these small ping pong balls, orange, to imagine a kilocalorie. So this is how the energy, attached with energy, that will produce a volume of air to increase the temperature. That's the notion of energy. And then we needed to go to per person. So we have this mappet. So each of these mappets, each one of the students produced 2 kilocalories. We will 2 kilocalories at these small balls. So this way they computed the whole energy that was needed. Yes? Now, we tried this during the whole year, and finally we want to describe now the cross-border public class. Means we had 3 classes. Maybe you...
Yeah, so one of the things I want to mention just a minute, before we did the cross-border lesson, there was actually, a pilot of doing a cross-border and anticipating how this could be done. And so initially, the jumping that you did was taken out of the cross-border, and instead the students utilized the data that was collected from the pilot lesson. But as a result, some of the feedback that was received from the researchers and the teachers as part of lesson study was part of it, what was interesting and engaging for students was providing that context of jumping, even if you were unable to collect the data that was being described. So for example, in the US, we have heating and air, just like we have air conditioning in here. So thankful for that. But it makes it more difficult, as Roberto has mentioned, to control the variables then, to actually impact the temperature. Because if you have central heat and air and you're trying to keep a constant temperature, the air conditioning is just going to blow harder as we are jumping, right? So really not impacting the temperature. So with that in mind, the idea is to simulate students actually still doing the jumping and being able to discuss what kind of energy and what kind of influences they have. So with that being said, we had 2 classrooms in Chile and 1 in the US that occurred, as well as we had a public class coordinator, Joseph, and I'm going to let him speak to just a minute because Roberto was the teacher. I call myself a teaching assistant in this aspect because I'm in one of the remote sites. And then we also had a colleague at one of the remote sites at the other Chile classroom. So Roberto, you wanted to speak to that?
Yeah, so my role in all of this was to connect the 3 classrooms together with one another, and at the same time connect those 3 classrooms to the rest of the world. So no small task there. We connected our experience with a meeting that was taking place in Lima of the APEC members, and at the same time other observers from around the world were able to watch this experience live. And so obviously that brings with it huge technical challenges. You can imagine that between 3 researchers here, we struggle to show a PowerPoint presentation on an iPad. The technical challenges of having 3 schools connected on different devices with different levels of connectivity and broadband connections. And so what we did was several trial sessions to try and anticipate what those problems would be come the time to implement a public class between 2 countries. And so we carried out a small-scale trial in Chile, and we worked out that the chances of the internet dropping in Chile, especially in the poorer areas, are quite high. So we made sure we had backup internet on hand. We also looked at how things like the audio-visual connection worked, whether or not we could have 3 video simultaneously playing through Skype, which is the software that we used. And so at the same time, I was video streaming this to our observers in Lima and the rest of the world, and I was able to have a very unique view of the experience as like an eye in the sky. Roberto was busy beating the drum and teaching his class in La Pintana, and Colleen was at a remote site in Texas, acting as a teaching assistant. I was able to see everything unfold and provide a running commentary to our friends in Lima, and at the same time intervene at different times throughout the lesson to be able to offer dual language instructions to overcome the language barrier.
Yes, I'm going to try to show some of the
So one of the things, while we're getting started here, we're started. Let go.
En este momento del Colegio Impact, que 2 alumnos se acerquen a la cámara y van a saltar al ritmo de Roberto. Y lo mismo
Yes.
a good example of how technology. So we can see now kids on camera from Texas and Inba. And we have the students from Colegio Santa Rita as well, jumping together to the rhythm of the drum that's been beaten there by Roberto. Reminder that this is 3 different classrooms, 2 in Santiago, 1 in Texas.
So as you can see, Joseph was actually giving commentary to those who were viewing, just like we're live streaming. I'm sure you're aware in the program that there's live streaming of the keynote speeches as well, and that's what Joseph was providing as commentary of what was occurring as people were viewing. And one of the things you'll notice is the placement of the furniture was really important so that the students could be viewed from the Skype area as well. Do you want to speak to anything else about just the
Yeah, so obviously as a classroom teacher, it's very easy to envisage how you want to set up your classroom. Okay, you might want them in a horseshoe, you might want them in lines, you might want people in groups. But here you have to take into consideration not only your own classroom, but the other 2 classrooms that are connected remotely. And so what we did there is, with Colleen, we set up another trial or another brief meeting where I, from a remote location, was helping Colleen and her colleagues to set up her classroom to be able to take part in a remote class, because they wouldn't have the advantage of the teacher being in face-to-face with their students. And so we needed to make sure that those students could see the class that would be taking place in Chile, but at the same time be able to interact with the teacher at a distant location. So
what he's speaking to right here is the students were actually, you think about, it was about students being able to engage with other students in another country. So the students were able to also see the other classrooms, which was really important. So this is the view from Texas occurring, and the students following along with Roberto here and watching the screen as it's occurring.
So one of the critical things is here how we make all of them participate. For example, if I ask a question like I was asking before, what are the variables? Maybe 1 or 2 or 3 of you will respond to me. But how can we have all of them respond every question? So we did questions, we did 4 questions online, and all the kids could answer on their tablets, each question. And we were looking at the answer on real time. First question was, what is energy and how much do you need per day? They have to think about this and try to estimate this. Second question was, after a while, is what variables cause the room temperature to increase? Think about this. After a while, they start thinking about volume. Third question, in the middle of the session, was, in 1 minute, each student produced 2 kilocalories. We compute that. How many kilocalories do they produce in a day? Explain why. So it was not multiple options. They have to explain the reasoning. And the fourth question at the end of the session was from the graph. The graph I showed initially that increased the energy capture per capita per day. Explain why there is a huge difference in the energy capture per capita between 15,000 years ago and nowadays. So now they were able to understand this graph. The notion of energy, kilocalorie per day, how much you get from food, and where comes the rest of the energy. Can you now think where comes all this energy? 50 times as our ancestors we capture per day. Where is this coming from? It's a huge amount of energy we're capturing every day. And developing countries are capturing less, but we want to be like Japan and the States. So where is this energy? Why we're using so much energy? So that were the questions that we asked them, and they have to answer online on their tablets.
So, as Roberto said, the idea was that students were answering on a platform on their tablets. And as Joseph described, there was a day before where he interacted with myself and the classroom teacher to make sure all these components, these technology components, actually worked. And it's always, to me, a bad omen when everything works perfectly and you can't really anticipate all the challenges that might occur. So as best as we tried, you will notice that in Texas, our students have handwritten responses to 2 of the questions before that you saw on the previous slide that students responded to. We actually went back to paper and pencil because the Wi-Fi for the wireless Wi-Fi for the students did not, it was not stable enough to maintain the platform.
It was one of the few technical issues we hadn't considered. The idea that the internet in the United States of America would not work. We'd thought about how we would have a plan A, B, C, and D for the internet in poor areas of Santiago, but we neglected to mention or raise this issue with our colleagues in the US.
And so I have to say, as an instructor, I'm usually pretty good about these things. So in my own classroom at the university, I'm used to having another Wi-Fi connection. But being at a school where that's not the case, it brought about the idea of I was unable to problem solve very quickly along with anybody else, by the way, and which is a personal hotspot, which I have, and I had another computer for which that could have been done as well. So when you think about cross-border lessons, that's something you definitely have to think about. Paper and pencil always works, but what it didn't allow was for the teacher to receive those responses instantaneously and be collected all at the same time. So these are just some pictures where you can see students are engaged, And you might notice in the background, the classroom teacher, we had the IT person right there with us as well the whole time, as well as some older students you might see. And these are our pre-service teachers from the university who were taking part as observers of the lesson, of a cross-border lesson as well.
Well, here's just the activity that they're doing and they're answering, and we have here the description of what happens. We took it from another researchers, the idea that what happened during the session. These are from minute 0 to 60. And this is, the teacher was talking to the kids mainly of ideas or objects. We had some objects, real objects, and when was a mixture of them. This also from minute 0 to minute 60, and the class we were doing an experiment here. I was asking a question online, here 1, 2nd, 3rd, and the 4th question, the question that I showed you and they were answering online. Here are non-online questions, like the ones I did to you before, and here was when I was lecturing, in this moment, lecturing. So this is in the description of, we have a transcription of the whole class, we were able to compute this. And here is the kids, some of them have this basic volume, they were thinking this was a cubic meter, and answering the questions online. And we were reviewing online what all of them were saying, not only the ones there. Interesting is 9% of the spoken words of the whole class was just from the students. But if we consider online responses, this completely changes. Here are some online responses that we had later 3 researchers and 3 teachers assessing them, how good were these responses. But if you consider these online responses, we have 66% of the words on the class were from students. So we completely changed the participation from something more centered in the teacher to something more centered on the student. And I think this is very important. We tend to think that technology is mainly for computing. This reminds me, Professor Ichan yesterday said, the Korean Trojan mouse. Maybe we're thinking just on computing, but we have to think also the technology as a communication device, across country, the cross-border, and listening to what all of them are saying and explaining. And so this communication part, I think is very interesting, and it's you cannot do it completely with just writing, because we want from several sides to hear all of them. So I think this is an opportunity there.
Yeah, so here I can talk you through again my role as the public class coordinator and some of the elements that we used in the class. So here you can see the students in Texas with their portable devices, where they're able to access the platform that was used to ask these questions to the students and to receive their responses. Here you can see the setup, how the students are able to see all 3 classes. And then finally, another element that I was responsible for, as I said before, interacting with the meeting in Lima and the other online viewers. I was able to switch between showing the different classrooms, showing different aspects of the classrooms and highlighting these through my commentary. But at the same time, I was able to show the online platform and the results as they came through in real time. So the people that were viewing this class as observers were able to appreciate the same, or they had access to the same information that the lead teacher, Roberto, had to use during the class.
So one of the challenges we had was actually internet connection in the U.S. What happened was the internet connection for the whole school district, so not for just the school, the whole district went down, not just wireless, but even the hard internet. So we actually were out of the lesson fairly early on before we got past, we got to question 2. So our students did not respond to question 3 and 4. And then video conferencing services, we use Skype. And as you know, if you've ever used Skype, it's not as reliable typically, and so we're looking at what are more reliable type video conferencing services. We've heard of Zoom might be a more reliable type of video conferencing service. And then the sound system is really important. Not the sound of the teacher. We actually had some challenges being able to hear and understand Roberto at the beginning of the lesson.
Yeah, so we'd already trialed how the audio setup would work in one of our trial lessons. And it worked perfectly because the teacher taught from a seated position with the computer right by him. So the microphone of the computer was able to pick up everything the teacher was saying. Okay, so we took this as our trial. What we were looking for was, is the audio working? Yes, it is. What we didn't think was, will the audio work if the teacher is not sat by the computer? Roberto's quite an energetic teacher. He likes to move around quite a lot. And as he moved away from the computer, the audio failed to be transmitted to the other classrooms. That was something that although we'd tested for it, we hadn't really tested critically as to we were sort of looking to prove our own hypothesis that the audio works, as opposed to think about, well, will it work in these different conditions? And so that's something that we need to think about for the future, is how can we mic up the lead teacher so that the audio isn't reliant on his being close to the computer.
So I think part of it is, we've mentioned a robotic system. So I'm used to using a platform called Swivel, which allows the teacher to have what we call a marker around their neck that picks up the audio and allows them to be able to move, such as Roberto was doing in the lesson, as well as having markers on tables where students picks up the audio from students. The key here is how can we have a robotic system that also allows the video conferencing capability as well. And then teachers in the remote location. So myself and the classroom teacher, we were very vital to the lesson as well. And what we realized was even more so than what we initially thought. So for instance, we discussed the difficulty in hearing the audio from the classroom that Roberto was in. A lot of times I had the lesson right there. I knew the question that he was asking and I was able to repeat it, and Joseph might even repeat it as well. And then also the materials that were used. You saw previously that there was a model of a classroom. It'd be great for the remote locations to have that as well. So to have those similar materials in the remote locations so students can have that connection that's occurring where the teacher is actually teaching.
Yeah, I think it's just trying to replicate that same student experience in the remote classrooms as the students that we're receiving in Roberto's classroom. That's really important to take into consideration. It's not the same watching a lesson via Skype as it is being in the classroom and interacting with the teacher. So there's some of the challenges that we're looking at working on for future cross-border classes.
Well, I think we want to thank the opportunity that Maitri and Masami has given us to try this completely disruptive innovation of way of collaboration and working together. But we have some questions, and let's think, we imagine that this is working. Once a month we do this kind of thing. So what we have to think, what is required to be ready for cross-border STEM classes? One is a technological issue we look at here. For example, a robotic system could be very efficient. It's a camera that follows you automatically. It's perfect. But also there are some coordination between teachers. We have to plan much better because remote teachers doing a common activity requires a degree of planning, coordination that we have to think about this. Another question is, three questions. Second, what will be the impact on social and emotional life of students? We did, with the class that was there, this is a very poor school, the 5% poorest area of Chile in Santiago. The other school is middle class and then Texas. We did the survey with the poorest school. They really enjoyed it. But one of the most interesting things for them is that they felt they are alike other students in other parts of the country, and of the world. This is something very valuable, particularly for kids from at-risk and vulnerable zones. The other one, what will be the impact on students' learning outcomes? We have for each one of the 4 questions, the kids wrote their explanation, and we have, as explained, 3 teachers blindly graded them and 3 researchers. Each of the questions, this was afterwards. And we discovered the following thing. We had the grades of the good students. These are only the Chilean students because they did it on the computer in the 2 schools. One school is a more talented school, the other school is this poor school. But we realized that there was no differences in gender on the grades. But the most interesting thing is that poor students that's below the average have the same grades as the good students. That something says to us that there is a motivational factor behind. And when these kids participate in this and see other kids of the world, these poor students, maybe it's not that they not have the abilities, that's the motivation, because their writing was comparable to the other ones. Because the raters, the 3 teachers and the 3 researchers that were grading this, they didn't know, was completely blind, the gender, where the school were these kids, and of course the grades. So I think it's a very interesting finding for us. We have to replicate, work all together with more data, but at least these are around 45 different kids from 2 schools, and we didn't see any difference in the kind of the quality of the explanation.
And just to add to that, from a teacher's perspective, is the relevance, that the students saw relevance of the content, not just because it's another objective to fulfill in the curriculum, but saw relevance of how this transcends across countries, which I think is really what we're trying to do here, is make those connections with the content, with students, that this is something that is real and is important all across the world.
Yeah, another question, but what will be the impact on teacher professional development? We think this is huge because it's the lesson study, the open class, public class, but now you don't need to move teacher to another place like all coming here. And each teacher is working with their own students and see the impact immediately and get immediate feedback from this network of teachers analyzing this class. So somehow the technology here, leverage all these powerful ideas of lesson study that could be done at lower cost and with much more power. That's what we think is behind it. So it's very, very interesting.
Yeah, so I think universities have a role in this, to work as partners because of the resources that we have, and work in collaboration with the schools to have these, to not put all the burden on the schools or on individual teachers, but do it together and really see it as a community of that we're here to help all children learn.
And then, what will be the impact on changing teaching practices? We think just the other teachers looking at what you're doing, and then all this process, we were 6 months adjusting the lesson, and we could analyze what we were doing, which is very powerful. So I think this is a very powerful tool to change teaching practices. I learned a lot from other teachers. I just produced the last class because the Chilean teacher didn't speak English. So I had to somehow do this part of it. But most of this work also was done for other teachers, and we just analyzing. So I think it's a very powerful tool for teaching practices. So, and what will be the impact of reducing teacher isolation? Most teachers work alone, just with the classroom. And this is a way to connect classroom. I think this is a very powerful, this collaboration, and to reduce this typical isolation. It's very different from other professions. It's more easy to connect. Engineers work together, but teachers mostly work alone.
So I think lesson study is a very important aspect of building learning communities. As I mentioned before, it's in collaboration. It's not doing to somebody, but with, as a community. That we are in this together. We are, as researchers, we want to work with teachers and with our schools and do this together and with our partners in other universities and in other countries as well. That we have greater potential when we work together than when we work individually and isolated.
So thank you very much.
Thank you.
Thank you.
Want any question and more about this? We're happy to talk with you and also to try with you. I think this idea of Maitri and Masami, we have learned so much these 6 months. Trying this, we think it's a very powerful tool.
Professor Masami?
Thank you very much. I observed the class from the Peru. And as I mentioned yesterday, Director General of the Higher Education Commission of the Thailand, he also jumped. And what is important, I very much impressed the class I observed. And I just want to explain how enthusiastic the activity it is here, little bit. And on the slide it says socio-emotional life of students. One of the points is that synchronization. There are two ways of synchronization. One is the jump. The one is using the ICT. The two ways of synchronization of the discussion. And that's just in front of this keynote, the previous keynote speaker, Professor Dr. Mark, talked about the peace development. And this kind of activity is actually deeply, I believe that, how can we develop the peace, such a mindset, it is deeply related to this activity. And yesterday, we have the physics education lesson study activities, and the children jumped through the rope, jumping rope, and children coming and jump. And another lesson study activity is waters. Such topics are very much important for sharing the ideas and working together. And actually, jumping activities produce the mindset for the synchronization of the different sides. I astonished. Very much interesting activities it was. And I would like to propose, in APEC lesson study project, we have been engaging in the cross-border lesson study activity like this. And here, there are participants from the Mindanao State universities and the Surabaya State Universities and the Hong Kong Institute of Education. Please participate in these activities. This activity means that from the Philippines, Dr. Urep, and from the Hong Kong is not here currently, but from the Indonesia, Kuitep Mas, there are people who are working on this project. So if you can connect and enlarge this movement, it is very much, good for the world to synchronize each other. And I just would like to use, thank you very much. I just say this point because of if you saw the video, if you will understand how it's synchronized. Thank you very much.
Thank you. Thank you very much.
Is you put the last before this slide, the challenges? Yeah, I very short comment. Yes, if you walk down there, in this floor, on the right hand side, we are preparing children for this. We are under construction, the new laboratory rooms that well equipped with this equipment, so that we can broadcast. And then this year we get support from the government to set this kind of equipment at 5 schools in project school. So next year we will challenge for this. Yeah, thanks.
Thank you. Thank you.
Thank you so much. And now I would like to invite the Dean of the Faculty of Education to present the token for the keynote speakers on stage, please.
Thank you very much. It's lunch time now, and before you go to have lunch, may I inform